Okay, you may want to gather around because we're going to go through some more code. I believe I have my system working now. So I don't remember where we left off last time. You guys probably don't remember real well either, but actually it would help if I got a cable and plug this in. Does anybody have a spare cable? You wouldn't mind grabbing one. Thank you. Anyway, remember we were trying to get PID control to work and all. I'm going to comment out some of my code and show you how it works now that it seems to be working well. In fact, when I plug it in, it should do its thing. Yeah, there we go. Since I've already got it downloaded and running, I'll go ahead and show you. I've got it set so that it initially moves over from the edge, and then it takes whatever profile I choose. I've got 3 profiles I've generated. I'll show you how I did that. It takes one of those profiles, which is just a series of points versus time, and commands different positions. It chooses a different set point for the PID loop. And then once it's done, it just stops. It comes back and stops. So if I reset this, you'll see it move. That way we can see it on camera. So there's the initial move to get it off the edge. And there it goes. I don't remember which profile I have operating right there. A little bit of jiggling at the end. It's because my PID parameters aren't quite perfect, but they're not too bad. Let me show you the code and how it works. Then I'll show you all the little things I had to do to get it to work. All right. I always forget to press off the screen a bit. There we go. Now, if you're watching this on video, what you'll want to do is download the code, and there will be some spreadsheets too. I forgot to copy those over from my computer, so I don't have them right now, but I'll end up basically recreating them as I talk to you. So all my definitions and things and variables are as they were before. So if you're watching this as part of the video series, you can just continue into this and you should be fine. I played around with how often my PID loop was computed. So remember last time it was 1,000 times per second? Well, it turned out that was so many times that I would lose counts. If the carriage was moving really fast on the slide, what would happen is it was spending so much time in the in the interrupt subroutine that it missed a transition. So what happens when an interrupt is set on one of the pins is there's basically a flag that's set in memory. But if you don't get to that flag, if the code doesn't get to the point where it takes care of that interrupt, tracking the encoder, and another transition occurs, well then the flag's just still set. So you can actually miss a count with the interrupt. So I had to play around with how often I computed, and I even did some work, here I'll show you that part. I even did some work trying to measure how much time each part of my interrupt subroutine that's time-based, it's doing the PID calculation. I had to figure out how much time it took to do all of this stuff, because this is quite a bit to do 1,000 times every second. And there is one change from last time. I changed error and D input to integers instead of doubles, trying to get the code to go a little faster. If you think about it, we're measuring position on the carriage. It's always integer numbers, right? There's never a need for a floating point or a double number. So just using an integer is fine for these variables. And I think it saves some time. I don't think I actually measured the difference on that part. I just assumed that a double would take longer to process than an int. Anyway, you'll notice near the end of the code that I've posted, I've titled it Copy of Essential Parts of PID ISR, that's the PID calculation, to measure execution time throughout code. Because if we're going to calculate this big long equation, you remember the proportional, integral, and derivative gains, or using those to calculate the output from the error, well then we'd like for that to take the minimum time possible. So setting mode manual, that's so it doesn't go into the actual ISR, and I had just this code running loop, which is essentially a copy of what's in the ISR. First thing I did was I moved the carriage to about the center point, and then I began the calculations that would normally occur over here. And what you'll notice is that I made an array where I could just note the time in microseconds after each instruction has been completed. Now, there's a problem here. Noting the time takes time also, right? So the microsecond clock is advancing while I'm basically jotting down how long the last command took. But at least it gives me an idea where the longest section of the code is located. It turned out that the conditions were fairly long, and if I could get rid of some of the conditional decisions, I could save a few clock cycles. But most of the work was in calculating the output. So for example, I put all of the PID calculation to calculate output from error, I put it all on one line. And that took the longest time. That took about 4 times what anything else took. The other thing that took a lot of time was the calculation here where I'm turning on the motor. So once I've got the output and then I want to scale it to actually set the pulse width modulation on, this map command took quite a bit of time also. So it was similar to the amount of time required for the PID loop calculation. And there wasn't much I could do. You'll notice here I'm using the map command. Down here I actually did the calculation more by hand, more manually. This does the same thing that's appropriate for this section. In other words, this bit of code here does the same thing the map command does here. All the map command was doing was mapping the output, which is going to be a number from 0 to 255 to forward min to 255. Remember, forward min is the minimum speed for moving forward. I also found a bug in my code from last time. I had set I as an unsigned variable, and in using it to measure the, let's see, where is that section of code? I was measuring the minimum speed or minimum setting to actually get the carriage to move. Remember we talked about that quite a bit last time. Anyway, there was a condition that said when I is less than or equal to 0. Well, if I is an unsigned int, I don't remember how it goes, but basically I had to go below 0 and it couldn't because it was unsigned. It was always positive. So what it would do is it would roll over from 0 to 65535 and keep going, and the condition was never met. So anyway, I fixed that bug. Wasn't a real critical one, it didn't matter. I still got the same minimum forward and reverse speeds. All right, so I spent a lot of time measuring the amount of time the ISR took, and then I wrote this bit of code up here. I put it near the beginning. Let me find it. Let's see, here we go. Yeah, okay, so here's checking the encoder phase. I wrote this bit of code to check the encoder counting at maximum speed. What I was concerned about, I was concerned that, well, if the carriage moves at maximum speed, can the interrupts themselves just keep up and count it? So I wrote code to check that, and basically the way it works is I turn off the PID control so it's not trying to move the motor. And then I basically just turn the motor on high to move forward, and then back and forward, and I just waited at the end of travel, but I did this over and over. That way, you know how when your carriage goes back and forth, a lot of times you'll notice it start to skip counts, right? And it'll start to move farther and farther one way. I wanted to see if that would happen. Well, it didn't. It was fine. It was rock solid. So turning on the motor full speed, I know that my encoder can keep up. There's no noise affecting me or anything like that. So that worked out fine. So then I said, okay, well, if it can move back and forth and not lose counts, can it do it while moving with PID? Because before, what I was doing is just turning the motor on full blast one way, change direction, turn it on full blast the other way, right? That's a pretty dumb, simple command. Could I instead say set point over here so that the PID loop makes it move over there, set point back over here so PID loop pulls it back, and go back and forth? So I wanted to do that 10 times also. So you'll see here, instead of turning the motor on, I just leave the PID loop enabled and set a target, a set point of 8,000, which is beyond the length of the carriage, but I just wanted to go as far as it could, hit it, and wait there for a little bit. That's what this 1.5 second delay is for. And then set the set point to -1,000, so it would go as far as possible to the other side. And then wait 1.5 seconds. So I did that 10 times also. So I had it slam against each end of the carriage over and over again. Well, this is where I found I was losing counts, because while it could keep up before by just turning the motor on and moving, if there was another bit of code, the PID loop, that was running 1,000 times a second, trying to check and see if the carriage had reached its position, it simply could not keep up. So what I did with this code is I played around with my PID loop frequency, and that's where I started reducing it from 1,000. I reduced it down to 500. That didn't seem quite good enough, so I reduced it down to 250. I left all of that in the code so that you could set your PID loop for those three settings right here. There's two things you have to do. You have to set the sample time, because that's the PID loop needs to know how much time has elapsed since the last calculation for the math to come out right. So you got to set the sample time. So right now I've got sample time set to 4, so every 4 milliseconds, that's how often the PID loop runs. That's the same thing as 250 hertz. But you could set it for 2, which is 500 hertz, or 1 millisecond, which is a kilohertz. The kilohertz didn't seem to work, and 500 seemed to be too often also. But 250 seems to perform fairly well. And so then down here, I've also got the code, and this is new. I've just typed this in today so that you guys could understand it. But I've also got code that's commented out, so you can set the interrupt frequency for either, let's see, 250 hertz, which is what it's set at right now, or 500 hertz, which is a different number. It's 499 on that register, or 1,000 hertz, 1 kilohertz, which was 249. This is what we were using last time, was the 249. So you got to set it both places, but then you can change the frequency with which the PID calculation occurs. Okay, so once I did that, once I had troubleshot and figured out, well, my PID loop is just moving too fast, I got it to a point where it was moving pretty well. So then I went back, and by the way, this section here, check encoder at maximum speed with PID, and this part, check encoder counting at maximum speed, no PID. Both of those are new sections of the code that you've not seen before. But all it really does is just move the carriage back and forth, one with PID and the other without. Other than that, once I got that figured out, what did I do? Trying to retrace my steps and remember what I had not shown you last time. Oh, I know what else I did. So once I got that done, I really wanted to tune it. The PID loop seemed to be working fairly well. So what I did is I turned on the PID Point Trail, where I just set a goal of 2,000. So the carriage moves to position 2,000, waits a second, moves to 3,500, waits a second, moves to 5,000, waits a second, comes back to 3,500, waits a second, comes back, and just goes back and forth between those positions. And I like this bit of code because it lets me just see how the PID loop is working. And so I was getting a lot better performance out of the PID loop. I could actually see oscillation with a proportional only controller. In fact, I'll show you that because this is worth seeing. So let's turn on this section of code by uncommenting it. And what this will do is just go back and forth between the 3 different points. Let me turn off everything else. There's 2 things I have to turn off. There we go. And if we run this, let's see, we want the PID loop on, so it should be, okay. So we run this. Oh, I don't think my port is selected. Yeah, drat. Yes, I know. I didn't tell you where to put it. Try it. It'll probably error out again. Yeah. One more time. Should be the charm. Nope. Let's just plug and unplug. This time I'll select the port before I try to download to it. What's it upset about? Undefined reference to main. Oh, that means I've got an extra bracket somewhere. Hang on, let me find it. I've probably commented out something I shouldn't have. Let's see, there's loop. That's okay. That's all right. All this is commented out, so it doesn't matter. No, maybe I made a mistake up here. Let's see. You are commented, so that's okay. No rats. That's strange.
Will it give you a line number on that?
No, it doesn't. It says undefined reference to main, and I remember I had this problem, and I think that it ended up being something in either in my ISR or a curly bracket somewhere that I had missed. But I know that this ISR is okay. I think it's okay. It was working all right earlier. I don't need that comment anymore because I did change it to an entity, and I know that works fine. And if you copy Brett's code online, he forgot a semicolon on one line, so I actually went back and recopied his stuff because I had made so many changes to the PID loop I'd forgotten where I was. So I went and copied his stuff and pasted it and found that semicolon error again. Let's do a quick compiling check instead of actually trying to upload. Yeah. Well, I don't want to waste your time or the video time. I'm going to pause the video because I know it's just a simple, stupid mistake somewhere. When we come back, I'll show you where it's at.